Welcome guys. So in this particular video, we are going to be talking about scalars and vectors quantity. Scalars and vector quantity. So in our previous video, we have talked about what physical quantity means in physics. So today we are going to be talking about scalars and vectors. So you have to understand something, you don't have to stress yourself too much. If you are talking about a scalar quantity, scalars, they have only magnitude. They have only magnitude, but no direction. So scalar quantities are quantities that has what? Only magnitude, but no direction. E.g., distance, density, speed, work, energy, power, pressure, and all fundamental quantities. So therefore guys, distance, density, speed, work, energy, power, pressure, and all fundamental quantities are the examples of what? Scalar quantity. We can also have what we refer to as vector quantity. Vectors, they have both magnitude. They have both magnitude and direction. So quantities that have both magnitude and direction are referred to as what? Vector quantity. E.g., displacements, velocity, acceleration, force, etc. So these are the examples of what? Vector quantity. So in this particular video, after we've talked about scalar and vector quantity, the next thing I'm going to be talking about now is the what? Unit vectors. So guys, after we've known what vectors are, quantity that have both magnitude and direction, then we are going to be talking about the unit vectors. So guys, we are talking about the unit vectors. The first thing you have to note about unit vector is that these are vector that has magnitude of 1. So the magnitude of unit vector is what? 1. Whenever you hear 1, the unit, it simply means what? Single. That simply means 1. Number 2, they specify direction. They specify direction. So unit vectors are vectors that have magnitude of exactly 1, and what do? They specify what? Direction. So what are these unit vectors? We can have the I unit vector. We can have the J unit vector, and we can also have the K unit vector. So we can have the I unit vector, J unit vector, and what? K unit vector. The next thing, I unit vector specify X direction. J unit vector specify Y direction. K unit vector specify Z direction. So therefore guys, the unit vectors we have the I unit vector, J unit vector, and what? K unit vector. So you have to know that the I unit vector specify X direction, the J unit vector specify Y direction, while the K unit vector specify what? Z direction. The next thing you have to note is that a given vector can be represented as So generally, there is a general way of representing a unit vector. And let's say vector A can be represented as AXI plus AYJ plus AZK. This is the general form of representing a unit vector, a vector. Also, let's say I'm dealing with vector B. That will be what? BXI plus BYJ plus BZK. So you have to note the general ways of representing a what? Unit vector. The next thing you have to note now, guys, is the magnitude or modulus of a vector. The magnitude or modulus of a vector. So if I have vector A, the magnitude of vector A can be written as this. This is representing the magnitude of vector A. So because vector has both magnitude and direction, on top of this vector A, I can put this. This is showing that it's a vector, it has a what? Direction. This also, I can put this. This is showing that what? Is a vector, it has a what? Direction. So the formula for magnitude of vector A is equals to, you just write square root. The coefficient of I, open bracket, write it there, AX, all squared, plus, open bracket again, the coefficient of J, AY, all squared, plus the coefficient of K, AZ, all squared. This is the formula for the magnitude of what? Vector. We can also write the magnitude of the vector as what? Modulus of the vector. The next thing you have to note is that whenever you hear the word orthogonality of unit vector is 90 degrees. So the orthogonality of unit vector is what? 90 degrees. And the last thing we have to know is that computation of unit vector. So they can ask you to compute the unit vector. Then you have to know this. Unit vector, the formula for unit vector equals vector given over magnitude of vector. The formula for unit vector is what? Vector given over what? Magnitude of the vector. So therefore, let's say I want to write the unit vector of A. So I'm going to be representing the unit vector of A as this, A cap. This A cap is the representation for the unit vector of A. So whenever you see something like A cap, B cap, simply means what? Unit vector. And that's equals to vector A. These are vector A over magnitude of vector A. So therefore, let's move on to the operations of unit vectors, guys. Okay, guys. So if we are talking about the operations of vectors, rather, you can have the addition and subtraction, and you can also have the what? Multiplication. So if you are talking about the multiplication of vector, we basically have two types. We have the scalar product. We have the what? Vector product. So let's talk about the summary of scalar products. These scalar products can also be referred to as dot product. That's the first thing you have to know. And what you have to know about the scalar product is that this is the multiplying a vector by another vector to get a scalar number. And the general formula for scalar product is what? A dot B equals magnitude of A, magnitude of B cos theta. The rules guiding the scalar product include I dot I is equals to 1, J dot J is equals to 1, K dot K is equals to 1. But if it is I dot J, J dot K, J dot I, J dot K, that's equals to what? 0. And the last thing you have to note under this scalar product is that the scalar product of two perpendicular vectors is what? 0. Also, we have the cross product. This cross product is also called the vector product. And this is the multiplying a vector by another vector to get a what? Vector. This cross product is defined by this formula, A times B equals magnitude of A, magnitude of B sine theta. And the next thing you have to notice is that the vector product of two parallel vectors is what? 0. The reason why the vector product, the scalar product of two perpendicular vectors is 0 is because for two perpendicular vectors, the angle between them is 90 degrees. So therefore, if I have A dot B equals to magnitude of A, magnitude of B, if the angle is 90 degrees, cos 90 will give me what? 0. So 0 multiplied by this is still what? 0. So that is why the dot product of two perpendicular vectors in which their angle is 90 degrees will be what? 0. Why also the vector product of two parallel vectors? The reason why the vector product of two parallel vectors will be 0 is because for parallel vector, the angle between them is what? 0 degree. So therefore, if I use this formula for parallel vector, the angle is 0. Sine 0 is going to give me what? 0. So 0 times magnitude of A, magnitude of B will still be what? 0 degree. So therefore, guys, let's look at example for magnitude, unit vectors, and the rest like that, guys. So we have this example, and these are various type of question they can ask you in exam. We have vector A equals this, vector B equals this. They asked you to look for this. Now, guys, the first thing we should do, the first question, is that we should look for the magnitude of A. Guys, do not forget that our vector A was equals to 4i plus 8j minus 3k, right? From the question. Our vector B was equals to 6i minus 3j plus 4k, also from the question. So therefore, guys, if I'm to do my magnitude of A, the formula for magnitude of A is going to equal square roots. Square roots. The coefficient of I is what? 4. You will open a bracket. The coefficient of I, that is 4, close bracket, square. Plus, you will open another bracket. The coefficient of J is 8, close bracket, square. Plus again, the coefficient of K is minus 3, open bracket, minus 3, close bracket, square. So this is how you are going to do it. Then guys, you are going to press this on your calculator. You are going to press this on your calculator. Okay, that is 4 squared plus 8 squared plus minus 3 squared. Guys, you are going to be getting root 89. So if you then press this in the decimal form, the magnitude of A is 9.43. This is the magnitude of A. Also, the next question asks us to calculate the magnitude of B. That also equals, we are going to write the square roots. This is our B. The coefficient of I, 6, open brackets, write 6, close brackets, squared, plus, open another bracket, the coefficient of J, minus 3, close brackets, squared, plus, open another bracket, the coefficient of K, 4, close bracket, squared. You will also press this on your calculator, that is 6 squared plus minus 3 squared plus 4 squared. That gives us root 61. And in decimal format, we are going to be getting it as 7.81. That's how to do the magnitude. The next thing we have to do, guys, the question number 3. We have to look for A plus B. A plus B. Your A plus B is very simple, but you have to have the understanding that whenever you have to calculate either A plus B or A minus B, you are to be adding or subtracting only similar unit vector. In vector A, there is 4i. In vector B, there is 6i. Everybody, what is 4i plus 6i? That gives us 10i. So 4i plus 6i, it gives us what? 10i. The next part, we have plus 8j minus 3k. So what is plus 8j minus 3j? That simply means 8 minus 3. That is what? 5. So this will be plus 5j. Also, we are going to be doing minus 3k plus 4k. We want to do minus 3k plus 4k. So what is minus 3 plus 4? That is what? 1. So this will be what? Plus k. So that's it. Also, we are going to be doing a minus b. A minus b. Also, guys, if you are doing a minus b, we are going to be subtracting similar unit vector. This is 4i, this is 6i. So I'm going to be doing 4i minus 6i. So it's as if I'm doing 4i minus 6i. What is 4 minus 6? That is what? Minus 2. So this equals minus 2i. Also, I'm going to be doing 8j minus 3j. So look at this. It's as if I'm doing something like 8j minus 3j. Minus times minus is what? Plus. So that will be 8j plus 3j. So what is 8 plus 3? That's equals to what? 11. That is plus 11j. Also, I'm going to be doing minus 3k minus 4k. So it's as if I'm doing minus 3k minus 4k. Minus 3k minus 4k, that is what? Minus 7k. So guys, the next question we have the magnitude of a plus b. So the magnitude of a plus b that I was expected to calculate is that I will firstly do my a plus b, then I'm going to look for the magnitude. My a plus b is this, so the magnitude will just be square root. The coefficient of I is 10, that is 10 squared, plus, open bracket again, the coefficient of j is 5, 5 squared, plus, open bracket again, the coefficient of k is 1, 1 squared. So therefore, you're going to press that on your calculator, square root 10 squared plus 5 squared plus 1 squared. Guys, that gives you 11.22. So the magnitude of a plus b is what? 11.22. Also, I will do the magnitude of a minus b. So in this case also, if I am to calculate the magnitude of a minus b, I will firstly calculate my a minus b, which I've done that and I got it. So that will just be open bracket minus 2 squared. The coefficient of I is minus 2 squared. Plus, open another bracket, the coefficient of j is 11. 11 squared. Plus, open another bracket, the coefficient of k is minus 7. Minus 7 squared. So therefore, guys, if I also press this on the calculator, that is minus 2 squared plus 11 squared plus minus 7 squared. I'm going to be getting a what? 13.1. 13.19. 13.19. So that's how to do it. The next thing, guys, is that I should look for a cap. Don't forget that once you hear the word a cap, it simply means unit vector of a. So the number, this is number 4, 5, 6. The number 7, which is a cap. Remember the formula for unit vector of a, that will just be vector a all over the magnitude of the vector. Don't forget, you can just put the arrow here to show that it's a vector. So vector a of the magnitude of the vector. The vector a given was 4i plus 8j minus 3k all over the magnitude of the vector a, that is 9.43. This expression here can be rewritten as 4i over 9.43 plus 8j over 9.43 minus 3k over 9.43. So if you press 4 divided by 9.43, so we are going to be getting this equals 0.42i plus press 8 divided by 9.43. That equals 0.84j, and press 3 divided by 9.43. That equals 0.32k. That's 0.32k. So that's how to do your A cap, the unit vector. Also, number 8, we were asked to do our B cap. So let me give you that as a classwork. Everybody, do this B cap and drop your answer in the comment section. Then let's move on to A dot B. A dot B. So whenever they ask you to calculate the A dot B, the first vector A is this, right? I will open bracket, that is 4i plus 8j minus 3k dot, open other brackets, B, 6i minus 3j plus 4k, close the brackets. You don't need to be using unnecessary long formula. What you are going to be doing here is the multiplication of similar unit vector. There is 4i here, there is 6i here. Just remember something, that your I dot I is 1, j dot j is 1, k dot k is 1. So this simply means you are going to be doing 4i dot 6i. Guys, 4i, if I'm doing 4i dot 6i, that simply means I'm doing 4 times 6, that is 24. I dot I, that is what? 1. So this simply means 4i dot 6i is equals to what? 24. Because 24 times 1 is what? 24. Also, I'm doing 8j dot minus 3j. So I'm doing 8j dot minus 3j. So that simply means I'm doing 8 times minus 3, that is minus 24. J dot j, that is 1. So this is minus 24 times, so that is what? Minus 24. Also, 8j, sorry, minus 3k dot 4k. So it's as I'm doing minus 3k dot 4k. Guys, what is minus 3 times 4? That is minus 12. What is k dot k? That is 1. And that is what? Minus 12. And that equals what? Minus 12. Because 24 minus 24 is what? 0. So that's how to do it. You don't need to be using any log method. And the next one is the angle between vector A and B. This is 7, 6, 7, 8, 9. Okay, yes. You know you are doing this as your classwork. Okay, the next one. Number 10. Angle. So whenever they ask you to look for the angle between two vectors, that simply means you are looking for theta. Guys, whenever you were asked to look for the angle between two vectors, you have to use this formula. A dot B equals magnitude of A, magnitude of B, cos theta. This is the formula you have to use. Then you are going to make this theta the summation of the formula by dividing both sides by magnitude of A. So your cos theta is equals to A dot B over magnitude of A, magnitude of B. And finally, your theta can equals, if this cos goes to the other side, can equals cos inverse A dot B over magnitude of A, magnitude of B. So this is the formula to get your what? Angle between two vectors. So therefore, since I'm looking for angle between two vectors, and I'm using this formula, so this simply means the first thing I should do is to get my A dot B. Since I have used this method, I've got my A dot B to be minus 2, I'm going to say that my A dot B is equals to minus 12. Also, I have calculated the magnitude of A. The magnitude of A I calculated was 9.3. Magnitude of A is equals to 9.4. 9.43 rather. Also, I'll calculate my magnitude of B to be 7.81. Magnitude of B equals 7.81. So therefore, guys, I'm going to be substituting these values into this general formula. Then my theta equals cos inverse my A dot B, that is minus 12, all over magnitude of A, 9.43, multiply by magnitude of B, 7.81. Therefore, guys, if you bring out your calculator, if you press shift cos, you press the fraction button, press minus 12, control the cursor down, then press 9.43, multiply by 7.81. Then control the cursor up and close the bracket, then press equals to your theta equals 99.38 degrees. So that is the angle between the two vectors. Guys, the last question I have here is to calculate the A cross B. So guys, follow me. To calculate the A cross B, we have different methods we use. We can use the 3 by 3 determinant matrix method. We can use the brackets opening method, and we can also use the calculator method. In our next tutorial video, I'm going to be showing you the calculator method approach for all these questions. So let's talk about A cross B. That simply means we have vector A, 4i plus 8j minus 3k cross, that is times 6i minus 3j plus 4k. I have this. Guys, you will firstly turn these two vectors into 3 by 3 matrix. By doing what? By doing this. Equal. You will write this. Write this. So you will see that in the two vectors we have ijk, ijk. So here I'm going to write I, J, K in the first row. The coefficient of I is 4. You will write it here, 4. The coefficient of J is 8, that is 8. The coefficient of K is minus 3, that is minus 3. If we also come down here, the coefficient of I in the second vector is 6. Coefficient of J is minus 3. The coefficient of K is 4. So we are going to formulate this. We have turned this vector into the 3 by 3 determinant matrix. The next thing we are going to do now is this. This vector, I'm writing it here again. That is I, J, K, 4, 8 minus 3, 6 minus 3, 4. So the method we are going to be using now is that you are going to be, in this first row, you are going to put plus here, minus here, plus. So you are going to put it as, we are going to put what there? Plus, minus, plus. Then the next thing we are going to be doing is that we are going to be using the determinant method. So how are you going to be doing it? Now, guys, this is the first row. This is the first column. So the first row, the first thing I have in the first row, that is plus I. I'm going to write plus I. Plus I will open brackets. So guys, I'm going to cancel this first row. I will also cancel this second row. We are going to see that what is going to remain is going to be 8 minus 3 minus 3, 4. So guys, you will write it like this. You will write it like this. 8 minus 3, 8 minus 3 minus 3, 4. The next element I have in the first row is what? Minus j. I'll just write it out. Minus j. Also do this. Now also, I will cancel the row of j. I will also cancel the column of j. That simply means this first row here, I will cancel it. The column of j, you know, this is the column of j. I will also cancel it. This simply means that if I should cancel this, I cancel this. It's going to remain 4 minus 3, 6, 4. So it's going to remain 4 minus 3, 6, 4. Also, the last thing here is plus k. I will write plus k. I will also write this. So therefore, guys, I will also cancel the row of k. I will also cancel the column. So if I should cancel this row, I cancel this column. What remains is 4, 8, 6 minus 3. 4, 8, 6 minus 3. So that is that. So therefore, guys, our A cross B equals. Now, what you are going to be doing now is that this is plus I, right? Open bracket. You are going to be multiplying diagonal elements. Use this 8 to multiply 4. Use this minus 3 to multiply minus 3. So this will be 8 times 4. That is 32 minus 3 times minus 3. That is what? 9. That is plus 9. Minus j. Also, use this to multiply this. Use this to multiply this. 4 times 4. That is 16. Minus 3 times 6, that is what? Minus 18. You will now open bracket and write minus 18. Close the bracket, close the general brackets. 4 plus k, open brackets. Also, 4 times minus 3, that is what? Minus 12. Minus. Then 8 times 6, that is what? 48. So therefore, guys, this simply means our A cross B would equals, what is 32 minus 9? That is what? That is 27. That is 27i. Now, guys, you have to be very careful here. You know we have minus 16. We have 16 minus 18. That simply means we are doing 16 plus 18. And this one is what? This is minus, that is plus. 16 plus 18, that is what? 34 minus 34j. This is minus 12 minus 48. Minus 12 minus 48, that gives us minus 60. This one gives us minus 60. Minus times plus what? This is minus 34j. And this is what? Plus 60k. So that is how to do it. So in our next tutorial video, I'm going to be showing you how to use the Casio 991 ES Plus calculator to solve all these questions. Thank you for watching. May God bless you.